Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over section 1.1a of our virtual calculus text. This will help you learn how to find algebraic limits by direct evaluation. For more resources to help you pass the AP exam, do visit our website at math.serve.com under AP Calc Exam Practice to get access to those resources. Alright, before we get started, let's take a look at the formula that we're going to be using for the problem solving process. The formula is as follows. Now, whenever you're evaluating finite algebraic limits, let's write that down. When evaluating finite algebraic limits, like the ones we're going to be doing in the examples today, we're going to use a procedure called Sally. Okay, so this is Sally returns. Remember, please excuse my dear Aunt Sally. Well, Sally's back again. Alright, so use Sally. What does Sally mean? Well, the first thing you will do when you're looking for algebraic limits, finite algebraic limits, is you want to substitute. Okay, substitute is the S in Sally. Now, sometimes when you substitute, you can get an answer, you can get an undefined result, or in certain cases, you get an indeterminate form. Okay? Now, when you have indeterminate forms, there are two odd ways that you can handle those scenarios. You can either use algebraic manipulation or L'Hopital's rule. Okay, so you substitute first, you can get either an answer undefined or indeterminate. For indeterminate, you use algebraic manipulation. Sometimes you could use trigonometric manipulation, but we could just classify it as algebraic manipulation, or a procedure known as L'Hopital's rule. These two are meant for indeterminate forms, okay? For indeterminate forms. Now, we do not cover indeterminate forms in this particular presentation. In the next two presentations, we're going to cover it. But indeterminate forms are answers that are of the form 0 over 0. Okay? We're not talking about a number divided by 0. If you have a number divided by 0, that's undefined. Okay? In that case, the limit does not exist. But if you have an indeterminate form, we're looking at a scenario where you end up with 0 divided by 0. Okay? So that's the meaning of Sally for you. You substitute first. If you get an indeterminate form, you use either algebraic manipulation or L'Hopital's rule to handle that case. In the examples we're going to be doing today, we're just going to deal with just substitution and evaluation, and then in subsequent presentations we'll take a look at indeterminate forms and how to use either algebraic manipulation or L'Hopital's rule to evaluate those limits. Alright, so the instructions for the examples we're going to be doing are for us to evaluate the given limits, algebraically by direct evaluation. Okay. Alright, so let's take a look at question 1. What if you have the limit as x approaches 3 of negative 2x squared plus 4x plus 4? Now let's talk a little bit about what this means real quick before we evaluate it. So what this expression is asking us to do is basically figure out what this functional component is approaching as x gets infinitely close to 3 from the left and the right side. Okay, we're not looking for what this function is, we're looking for what this function is approaching as x gets infinitely close to 3 from both sides. Okay, alright, let's go ahead and do this using algebraic evaluation. So if you think about the procedure we talked about, we're just going to substitute using Sally. So what does that look like? We have limit as x approaches 3 of negative 2x squared plus 4x plus 4. So what that S and Sally means, the substitute basically means that the value that x is approaching, just simply substitute it for the x's in the function. Okay, so we carry out the substitution. We have negative 2 times 3 square plus 4 times 3 plus 4. Okay, let's go ahead and use the order of operations to simplify this expression right here. Exponents first. Negative 2 times 3 square is 9. And then we can multiply 4 times 3. That's 12 plus 4. And then we have negative 2 times 9, negative 18 plus 12 plus 4. Negative 18 plus 12 is negative 6 plus 4. That gives us negative 2. So this is what the function negative 2x squared plus 4x plus 4 is approaching as x gets infinitely close to 3 from both sides. Alright, let's take a look at another example. So let's say we have to evaluate the limit as x approaches 1 from both sides of x plus 2 divided by x squared plus x plus 1. Now, we were talking about finite limits. Now, how do you know if a limit is finite or not? All you have to do is look at what x is approaching. Okay? If x is approaching a number, then you know it's finite. But if x were approaching infinity, positive or negative infinity, then in that case you have an infinite limit. Alright, we're going to address infinite limits later on in this sequence of tutorials. Alright, but in this presentation we're looking at finite limits, a scenario where x is approaching a finite number that's basically not positive or negative infinity. Okay. Alright, so we're doing this algebraically by direct evaluation. So we're going to be using Sally again. S means you substitute. Alright, so we have the limit as x gets infinitely close to 1 from both sides of the function. So the function x plus 2 over x squared plus x plus 1 gets infinitely close to what? That's the question. So we're going to substitute and see what happens. Alright, if we substitute, we have 1 plus 2 divided by 1 square plus 1 plus 1. Okay, well, let's go ahead and simplify that. 1 plus 2 is 3. In the denominator, 1 squared is 1 plus 1 plus 1 is 3. 3 over 3 is 1. So as x gets infinitely close to 1 from both sides, this function x plus 2 over x squared plus x plus 1 gets infinitely close to, or it approaches, the value of 1. Alright, let's take a look at a radical function situation. Consider this case. Let's say we want to evaluate the limit as x approaches 0 of the third root of negative 2x minus 5. Okay. Now, what kind of limit is this? This is a finite limit. Remember, whatever x is approaching, if it's not positive or negative infinity, then it's a finite limit. Alright, so we're going to be using Sally here since we are finding a finite limit algebraically. So we substitute. So we have the limit as x approaches 0 of the third root of negative 2x minus 5. So substitution means that we're going to plug in what x is approaching into the function. So we need to find out what is the third root of negative 2 times 0 minus 5. Okay. Alright, so if we do that, we have the third root of negative 2 times 0 is 0 minus 5. Okay, and 0 minus 5 is just negative 5, so we're looking at the third root of negative 5. And since the cube root function is odd, then this is just equal to negative cube root of 5. Okay, and that, ladies and gentlemen, is the value that the function approaches as x gets infinitely close to 0 from the left and right side. Alright, let's throw in some rational terms into the mix and see how that looks like. So let's say you want to find the limit as x approaches 2 of the function negative x squared over 2 minus x plus 3 over 2. Alright, so what kind of limit is this? This is a finite limit, and we are asked to evaluate it algebraically. So we're going to use Sally. We're going to substitute first. Okay? Alright, so let's carry out the substitution. We have the limit as x approaches 2 of negative x squared over 2 minus x plus 3 over 2. So if we carry out this substitution, we're going to have negative 2 squared over 2 minus 2 plus 3 over 2. Alright, so we have to deal with these fractions. I'm using order of operations. Let's go ahead and simplify this. 2 squared is just 2 if you divide that by 2. 2 squared is 4. If you divide 4 by 2, you have 2. So negative 2 minus 2 plus 3 over 2. Okay, so that becomes negative 4 plus 3 over 2. So we need to write 4 as an equivalent fraction with the denominator of 2. Okay, so we just multiply by 2 top and bottom. And that yields negative 8 over 2 plus 3 over 2. Now that the denominators are the same, we can just subtract the numerator and keep the denominator, and that's your answer. This is what this quadratic trinomial approaches as x gets infinitely close to 2 from the left and the right side. Now let's take a look at trigonometric functions. Alright, same procedure applies. So let's say you want to find the limit as x approaches pi over 2 of negative cosecant x. Okay? Alright, so what kind of limit is this? Even though it's a trigonometric function, that doesn't tell us what type of limit it is. We're looking at what x is approaching. Okay? X is approaching a finite number, so this is a finite limit, and we're asked to evaluate it algebraically, so we're going to use Sally. So we substitute first. Okay, so we have the limit as x approaches pi over 2 of negative cosecant x. Now we're going to just substitute pi over 2 for x, so we have negative cosecant pi over 2. Now some of you might like to work with cosecant, but I'll rather convert it to a more familiar function. You gotta remember that the relationship between cosecant and one of the parent trig functions, you want to recall that cosecant theta is what? Is 1 over sine theta. Okay. Alright, so we can then rewrite this as negative 1 divided by sine theta. Sorry, divided by sine pi over 2 since theta is pi over 2. Now let's go ahead and use our unit circle to do this. You can use your unit circle if you want, or you can use the sine function. I'm going to show you both ways of doing it. Whichever one you like, you can use. Most of my students prefer using the unit circle. Alright, so sometimes unit circle is better, other times using the graph is faster. In this particular case, I think using the graph is much faster. Alright, so where is pi over 2 on your unit circle? This is 0. And then if you go quarter of a circle, that's equivalent to pi over 2 or 90 degrees. Okay, so this is the point we're looking for right here. On your unit circle, you have to remember your coordinates. This is 0 on the x and 1 on the y. Okay, so what's the connection? Think back to trig. Sine, which is what we're looking for, is the y coordinate. Okay, cosine is the x coordinate. So the point that we're dealing with here is 0, comma 1. So the y coordinate is basically what sine of that angle is. So what I'm saying in essence is sine of pi over 2 is 1. Alright. Now let's say you wanted to use the graph to do it. Let me just show that to you real quick. You just have to remember what the graph looks like. The graph is pretty good for multiples of pi over 2. So your sine function looks something like this. So it goes starting from 0, it goes up to 1, and then back to 0, and then down to negative 1. Let me try that again. So like looks something like this. And then down here, and then right back to 0. Alright, so this is your parent trig function, right? So you know that you're going by multiples of pi over 2. So this is pi over 2, and that's pi, and this is 3 pi over 2, and then the last one is 2 pi. You know that the maximum is 1 and the minimum is negative 1. So you can see from our graph here that sine of pi over 2 is 1. So if you want to use a graph, that's how you do it. Anyway, we've concluded that sine of pi over 2 is 1. So we can just substitute that here. And we'll have negative 1 over 1, which reduces to negative 1. Okay? So ladies and gentlemen, as x gets infinitely close to pi over 2 from the left and right directions, negative cosecant x approaches the value of negative 1. Alright, let's go ahead and try another trig example. Okay, so number 6. Let's say you want to find the limit as x approaches pi over 6 of negative 2 cosine 2x. Okay. Alright, so what kind of limit are we dealing with here? This is a finite limit since x is not approaching plus or minus infinity. We're asked to use algebraic method. We're going to go ahead and use Sally here. So we're going to substitute. We have the limit as x approaches pi over 6 of negative 2 cosine 2x. So we're going to substitute what x is approaching into the function. So it becomes negative 2 cosine 2. Instead of x, we're going to replace that with pi over 6. Okay. Alright. Simplify further. We have negative 2 cosine. 2 goes here 1, 2 goes here 3, so it's going to be cosine pi over 3. Alright, so this is not a multiple of pi over 2, so I don't recommend using the graph here. The unit circle will be better will be a better option to evaluate this right here. Or some of you already have it memorized and you already know what that is, which is excellent. Let's just assume that we don't know what this is. So let's go ahead and graph it on the unit circle. Now, if you haven't memorized your where pi over 3 is, you can just easily convert it to degrees. So pi over 3, if you want to convert that to degrees, just to give you a visual as to where it's at, you multiply it by 180 over pi. Okay, 3 goes here 1, 3 goes here 60, and then the pi's cancel out. So pi over 3 is equivalent to 60 degrees, which is in the first quadrant. In your unit circle, you know, in each quadrant you have 3 points. Okay, you have the 30-degree point, the 45, and the 60-degree point. Okay, those are the reference angles. So we are in quadrant 1, so we're looking at this right there, the 60-degree point. That, ladies and gentlemen, is pi over 6. Okay. All right. So this is pi over 6. What are the coordinates? No, it's not pi over 6. Sorry, I meant to say pi over 3. This is pi over 6. This is pi over 4, and that's pi over 3 right there. Okay, let's just put it in just for kicks. Okay. Now, what are the coordinates here? You can just use the axis coordinates to guide you. So we talked about this earlier. This is 0, comma 1. So the point next to it, right after 0, is 1/2 in your sequence of points for the unit circle, and before 1 is root 3 over 2. Okay? So we know what cosine is, right? Sine is y. We talked about that earlier. Cosine is x. So the point under consideration is 1/2, comma root 3 over 2. So do you see what cosine of pi over 3 is? It's basically the x coordinate here. So it's going to be 1/2. Okay, so cosine of pi over 3, or 60 degrees, is 1/2. And that also tells us that sine of the complement of 60 degrees, which is 30, is going to be the same thing. So cosine of pi over 3 is the same thing as sine of pi over 6. Anyway, that's just by the way. So let's go ahead and finish off the problem. So we have to just replace cosine pi over 3 with what it's equal to, which is 1/2. Okay, so negative 2 times 1/2 is negative 1. Now, ladies and gentlemen, this is what negative 2 cosine 2x approaches. It doesn't have to get there, okay? For a limit, remember, you do not have to get there. The point does not have to be defined. This is what it is approaching as x gets infinitely close to pi over 6 from the left and right directions. All right, let's go ahead and try one last example. This is going to be real quick and straightforward. Number 7, what if you were asked to evaluate the limit as x approaches 7 of 3? All right, so this is a finite limit. We're evaluating this using algebraic method, so we're going to substitute. So we have limit as x approaches 7 of 3. All right, so where are you going to substitute 7 into? There is no variable that you can substitute 7 into. Ladies and gentlemen, f of x equals 3 is a constant function. Okay, so whatever x is, guess what? The function is going to constantly be what? 3. So this limit is simply 3 because it's a constant function and it's independent of where x goes. So x can do whatever it wants. The function will always approach 3. Okay? All right, so that's that. Now, how well did you understand the contents of this presentation? Well, I would like you to try out the following problems. Alright, so go ahead and try these. What we'd like you to do is just copy down the problems, pause the video, work them out, and then click on the play button, and then you will see the answers. Okay, so let's go ahead and try out these problems. So the task is to evaluate the given limits by direct evaluation. Alright, number 8. Let's say you're looking for the limit as x approaches 2 of -3. Number 9. What if you're to find the limit as x approaches 1/2 of -2x minus 3? Number 10. What if you're to find the limit as x approaches -1 of the square root of 2x plus 4? Number 11. What if you're to find the limit as x approaches -2 pi over 3 of 2 cosine x? Number 12. What if you're to find the limit as x approaches pi over 2 of -2 sine 2x? For 13, what if you're to find the limit as x approaches 0 of x to the third minus 2x squared plus 1? Number 14, what if you're to find the limit as x approaches 0 of x plus 1 divided by x squared plus 8x plus 16? Number 15, what if you're to find the limit as x approaches 3 of negative the cube root of x plus 5? Number 16, so you have to find the limit as x approaches pi over 4 of 2 tan x. And then lastly, number 17, what if you to find the limit as x approaches negative pi over 3 of 2 cosecant 2x? Alright, so we'll give you, go ahead and pause this video, try out these problems. When you're done, you can click on the playback button to see what the answers are. Alright, so hopefully you had a chance to try out the problems. The answers to the problems are as follows. Number 10 is -3. I'm sorry, number 8 is -3. 9 is -4. 10 is √6. 11 is -1. 12 is 0. 13 is 1. 14 is 1 over 16. 15 is -2. 16 is 2. And 17 is -4 √3 over 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of limits, to give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments or requests, just post it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to the remainder of this Vtext collection. More worksheets, videos, games, and tools to help you pass the AP exam can be found at mathgotserved.com. Do check it out. Thanks again for watching, and have a wonderful day. Goodbye.